Hello Math 2, this is Mrs. Bricky, and this video is for Math 2, Unit 2, Lesson 2. Today we'll be working on solving equations with binomial squared, with squared binomials in them. So I first want to start by just solving a couple of more equations similar to the ones that we solved in the last lesson. So these ones are maybe a little bit more complicated because they have more terms, but it is the same idea. When we're solving an equation that contains an x squared in it or a couple of x squareds in it, we want to isolate the x squared on one side of the equation. And then we can use the square root to both sides of the equation to finish solving. So if you think about sort of the like terms in this, we do have a 3x squared and a 2x squared that are being added together. So those add together to give us a 5x squared. And then you might notice that we have several constants in this equation. On this side of the equation, we have a 78 and a 4 that are being added together. We also have a 2 over here. So what I want to do is bring the 2 to the other side. It's an added 2 right now, so to undo it, we're going to subtract 2 from both sides of our equation. These 2 cancel out, and then we can combine all of these constants all together. 78 plus 4 minus 2 gives us a total of 80. So we have simplified that equation quite a lot, but we still have not isolated the x squared term. So what we want it to not have a coefficient of 5. So right now that x squared is being multiplied by 5. So to undo that and to get that x squared isolated, we want to divide both sides of our equation by 5. That's going to reduce to a coefficient of 1. So we've got x squared is equal to, and when we divide 80 by 5, we get 16. Now we have isolated our x squared term, and when we have that x squared isolated, that means we're ready to undo the power of 2. We undo a power of 2 by using the square root operation applied to both sides of the equation. And remember, there are 2 answers that make this equation true, so we're going to put a little plus and minus symbol right there to get both of those answers. So on the left side of the equation, the power and the root undo each other, leaving us with just an x. And over here we get a positive and negative 4. So those are our 2 answers. Remember, the plus and minus symbol is just shorthand. You could choose to write it like with a comma instead, or you could choose to list them if you wanted instead. Those all mean the same thing. This one is just shorthand. Okay, our next equation, we have x squared terms on both sides of the equation. You can see that we have 2x squareds over here, and then on the other side, we've got 2 terms that have an x squared, and those would combine to give us a total of 4x squared. I prefer, when possible, to avoid having a negative coefficient, so I'm going to choose to subtract the 2x squared and bring it over here. Because my x's are going to this side of the equation, I'm going to take the numbers to the other so that they're on opposite sides. So I'm going to add 31 to both sides of the equation. So this is canceled out and this is canceled out. So on the left side of my equation, I have a negative 7 and I'm adding 31. So that gives me a total of 24. And on the right side of it, the equation, I have a 1x squared, a 3x squared, and a negative 2x squared. So when I combine those terms, I get a total of 2x squared. Okay, so we've gotten our equation simplified quite a bit, but we still have a coefficient on our x squared. So we want to divide both sides of our equation so that we just have 1x squared. And now we're ready to apply our square root. So we apply the square root to both sides of the equation. And again, the reason we do that is because we're trying to cancel out this exponent of 2. So on the right side of the equation, we just have an x. On the left side, we have positive and negative root 12. And root 12 simplifies to be 2 root 3. And that is our solution. And again, remember that's just two answers in shorthand, positive 2 root 3 and negative 2 root 3. So if you prefer to write those separately to keep track, you definitely can. Okay, well, last unit we talked a lot about expressions, and one of the things that we learned how to do is we learned how to square a binomial. In this unit, we are focusing on equations, not expressions. So in our problems, our goal is going to be to solve for x. So I want to kind of emphasize the difference between what we did last unit and what we will do this unit, because they definitely are different processes. Last unit, we had expressions like x plus 3 squared. There's no equal sign here. It is not our goal to solve for x. If it asks us to simplify it, it's asking us to write it in standard form. And so we would multiply out all of those terms, x squared plus 3x, and then distribute the 3 to get another 3x and a 9. And then our final answer in simplified standard form would be x squared plus 6x plus 9. We simplified an expression and reported our answer in standard form. So that was last unit. This unit, we are solving equations. Our goal is to say x is equal to these two numbers. And so when we're solving equations, we are not going to be multiplying out that binomial squared. Instead, we are going to use a square root to undo the power of 2 as we go about trying to get that x by itself. So as an example here, x plus 3 squared minus 5, we would start by adding 5. And now we have x plus 3 squared is equal to 16. And now we can apply our square root to both sides. Now we can't subtract 3. Sometimes people want to go ahead and subtract the 3 here, but we can't do that because this exponent and these parentheses, they're essentially locking that 3 in with the x. Those two are together. The x is with the plus 3 in that grouping symbol. So we can't subtract 3, but we can undo the power by applying a square root to both sides of the equation. And the power of 2 right here, it cancels out that root, or the root cancels out that power, however you're thinking about it. And so on this side of the equation, we have an x plus 3. Now, because it doesn't have a power anymore, because that power got canceled out or undone by that root, we don't need our parentheses anymore. We still have the x plus 3 together, but that's the only thing on that side of the equation, so we don't need any grouping symbols around it. And then on this other side of the equation, we have a positive and a negative 4. So we want to continue solving our equation for x, and maybe you can see that we need to subtract 3, but it's a little bit tricky because we actually have two different numbers over here on the right. So at this point, we like to split it into two equations. X plus 3 is equal to 4. Or the other equation that we need to solve is x plus 3 is equal to negative 4. So we have these two equations. We split it up into separate equations because we really have two different numbers there. We have positive 4 and negative 4. And those are very different equations with very different answers. So now that we have the equation split into two equations, we can go ahead and finish by subtracting 3. And so we get x is equal to 4 minus 3 gives us 1. So that's one of our answers. We're halfway to our goal because we need another answer. Over here on this equation, if we subtract 3, we end up with x equal to -7. So that's our second answer. So we do have two answers to equations like these when we have an x with the power of 2. They aren't always positive and negatives of the same number. So in this case, our solutions were 1 and -7. So we're going to try a couple of more equations like this because these are a little bit tricky to get the hang of. So we're going to start this first equation by adding 43. So we're trying to isolate the binomial squared. So you want to get the x plus a number squared isolated. So we add 43. And so on this side of the equation, we have an x minus 6 squared. And on the other side of the equation, when we add the 38 to the 43, we get 81. So now that we have that square isolated, we're ready to undo it by applying a square root. And we put our plus or minus symbol because we know that that means there's going to be two answers. We know that x minus 6 could be either +9 or -9. So we take this and split it into two equations. That x minus 6 might be 9. That's one answer. The other answer comes when x minus 6 is equal to -9. And then we can continue solving those two equations. On this one, we add 6 to get the answer x is equal to 15. For our second equation right here, we add 6, and -9 plus 6 gives us -3. So we have the answers 15 and -3 as our two solutions. Now remember last time, no, sorry, I don't want to do that right now. I just want to solve the next equation. Sorry, I was getting ahead of myself. Okay, so let's see. 2 times x plus 10 squared minus 37 is equal to 13. So I'm going to start by adding the 37 to both sides of my equation. So now I have 2 times x plus 10 squared, and that is equal to 13 plus 37 gives me 50. I'm not ready to apply the square root yet. I have a multiplier of 2 right here. It's this binomial squared is being multiplied by 2. So before I'm ready to apply the square root, I need to divide both sides of my equation by 2. 50 divided by 2 gives me 25. And now that I have that power of 2, that binomial squared isolated, now I'm ready to apply a square root to both sides of my equation. So on the left side, I have an x plus 10, and on the right side, the square root of 25 is 50, and we of course have the plus or minus there. So we're going to take this equation and split it into two equations. The x plus 10 is equal to 5 for one of our solutions, and the x plus 10 is equal to -5 for our other solution. And so if we continue solving, we'll subtract 10. That gives us an answer of -5. And we also subtract 10 here, and that one gives us the answer -15. So we can have both answers negative. We could have both answers positive. We could have a positive answer and a negative answer like we did on the prior problem. Okay. You can, if you have the paper assignment and you want to practice that a little bit, that would be great. Let's revisit the number system, the real number system. Remember, last time we talked about irrational numbers. An irrational number is a number whose decimal expansion neither terminates nor repeats. It's a number that is not able to be written as a ratio of integers. and irrational numbers are often a result when we take a square root. Well, here are just some examples of irrational and rational numbers. Again, we talked about these a little bit in the last lesson, but here's just another chart showing you some examples of those. We want to see what happens when we do some operations with these numbers. So if I want to add the rational number 3 to the irrational number 7, what sort of answer do I get? Is it a rational answer or an irrational answer? Well, if you try doing that in your calculator essentially just gives it right back to you. So if your calculator gives you an answer that has that radical in it, that is an irrational number. If you wanted to look at the decimal expansion of this number, it is 5.64575131 ... This is definitely an irrational number. And anytime we add a rational number to an irrational number, our result will be irrational. Next, we want to multiply those two together. 3 multiplied by root 7. When we multiply 3 by root 7 in our calculator just gives us 3 root 7. And again, if your calculator is giving you a result with that radical in it, that is an irrational number. The decimal expansion of this is 7.93725539 ... It goes on, and this is an irrational number. When we multiply a rational and irrational number together, our result is an irrational number. Let's try adding two irrational numbers together. Let's try adding together root 50 and root 8. So if you have your calculator, try typing this in and see what you get. I put it into my calculator, and my calculator gave me the number 7 root 2. So this is an irrational number. Decimal expansion is 9.899494937 ... It's an irrational number. When we add two irrational numbers together, we can get an irrational number. It is also possible to get a rational number. That's not something to worry about, though. Let's try multiplying two irrational numbers together. Let's try multiplying root 50 by root 8. When I multiply root 50 by root 8, my calculator gives me the number 20. That is very much a rational number. Sometimes when we multiply two irrational numbers together, we get a rational answer. Not all the time, but sometimes. So if you're ever wondering if an operation is going to result in an irrational or rational number, I would use your calculator to perform the operation and see what the result is, and then decide if that result is rational or irrational. Okay, we're going to go back to solving equations, and we're going to have some other sorts of interesting answers come up. So first, I want to solve this pretty simple equation, x squared equals 60, and then we'll look at a slightly more complicated version of that equation where x minus 7 squared is equal to 60. So this first equation, we are ready to apply the root, which is going to undo that power of 2, and we end up with x is equal to positive and negative. And if you simplify root 60 in your calculator, you get 2 root 15. And those are our two answers to this equation. On this equation on the right, we also are ready to apply the root. We just have this x minus 7 squared, so our power of 2 is isolated. We're ready to apply the square root. And we end up with, on the left, x minus 7, and on the right, we end up with plus or minus 2 root 15. So the main difference here is that we have that minus 7 with the x. Well, our goal is to solve for x. That means we need to add 7. So in our other equations, we would try splitting this, and we could split this one if we wanted. I'll kind of show splitting it down here. So we would split it into the positive 2 root 15 and the negative 2 root 15. And I'll come to that in just a second. But because we have this irrational number over here, we could just think about adding the 7 straight away. And what we end up with is this number 7 that we need to add a 2 root 15 or subtract a 2 root 15 from. And those numbers, they can't combine. The 7 can't combine with the 2 root 15. So our answer ends up looking like this: 7 plus or minus 2 root 15. And that is two separate answers. If we kind of did it with the separate equations here, we would have a 7 plus 2 root 15, and then we would have a 7 minus 2 root 15. So the plus or minus, again, is still just shorthand for these two answers: 7 plus 2 root 15 and 7 minus 2 root 15. But those two parts, this rational part and this irrational part, they cannot combine. And so this is our answer, and this is our answer. Similar to combining like terms, irrational numbers can only be combined if they have the same radical part. So if I have a 2 root 15 and I want to add it to a 7 root 15, I absolutely can. I have 9 root 15, and that works great. But if I have a 2 root 15 and a 7 root 5, they can't combine because this radical part and this radical part are different, so they have to stay separate. And also, if I have a rational part and an irrational part, I cannot combine it. It just stays. Now, I definitely could figure out what decimal value that sum has. For example, 2 root 15 plus 7 root 5 has a decimal value of 23.39844 dot dot dot, but I can't write this in a more simple way. I can't combine those radicals together in a simplified expression. And again, 7 plus 2 root 15, I can't combine those terms. It is equivalent to a number. It would be, the decimal expansion of this would be 14.7459 dot dot dot. But again, I would just write my exact answer like this. I don't want to write it as a decimal. Okay, we have two more equations here to solve, and then we're going to talk about checking our answers. So I've got x minus 2 squared minus 24 is equal to 0. So I want to get that binomial squared isolated. So I'm going to add 24 to both sides of my equation. This gives me x minus 2 squared is equal to 24. I'm ready to apply the root to both sides of my equation. And when I apply that root, I get x minus 2 is equal to positive and negative 2 root 6. And again, if I get that 2 root 6 using my calculator. Okay. So I'm not quite finished. My goal is to solve for x, and right now I have x minus 2. So I need to add 2 to both sides of the equation. Well, in this case, I can't combine this 2 with this irrational 2 root 6. So my final answer is 2 plus or minus 2 root 6. Sometimes students will write the answer like this and put the plus 2 over on the far right side. That is technically correct. Again, we kind of run into that issue of like, how long is your root? Did it accidentally go over the plus 2 a little bit? So because of that, we would prefer that you write the 2 in front of the plus or minus symbol. And also definitely the plus or minus symbol is with the 2 root 6. It is not with the 2. So it wouldn't be, we absolutely would not have an answer of 2 root 6 plus or minus 2. That would be completely wrong. The plus or minus is with the 2 root 6. The 2 root 6 can give us a solution if it's positive and if it's negative. But that 2 is being added to that left side or that right side of the equation. So the 2's sign is definitely positive. So this one is okay, but not preferred. This would be our preferred answer right here. Okay. Let's try another equation. I want to go back to the ones we started with, and just so you can kind of on this screen see our 2 different types of answers. So we are going to add 16, kind of similar to we did on our last problem. Now we have an x plus 1 squared is equal to 16. We're ready to apply our root to both sides of our equation. We end up with x plus 1, whoops, I don't need a parenthesis anymore, is equal to positive and negative 4. And then we want to finish up by subtracting 1. So at this point, you have 2 options. Your first option is you can separate the equations. And the reason I'm separating them is because I can see that I have a rational number right here. This is a rational number, so I know I'm going to be able to combine. This one was irrational, so I knew I was not going to be able to combine. So if you want to, you can separate it into the 2 equations and finish up finding your answer this way. Or you can, from this step up here, subtract 1, but just remember that what you have is negative 1 plus and minus 4. So then in your calculator, you could, or in your head, you could do negative 1 plus 4, and you could do negative 1 minus 4. The 1 was subtracted, so the 1 is negative. The 4 takes on both signs. It's a both plus 4 and a minus 4. So the 2 answers, either way, you get the same 2 answers of 3 and negative 5, but you can kind of decide if this approach is good for you, or if you rather split it into 2 equations, you can do it that way as well. So just decide which way you like, splitting it into 2 equations or kind of carefully combining without splitting it into 2 equations. Okay, our last thing is, how do we know if the answer we found is right? How do we know if 3 and negative 5 really are solutions to that equation? Well, you have 2 options for finding out if you are correct. You could go back through your work and just try to check it and make sure your steps are correct. But for some students, that's difficult. Your second option is you can substitute your answer back into the equation and see if it makes the equation true. So if your equation, for example, is 2x squared equals 32 and you got an answer of negative 4, you could sub it in and then check in your calculator to see if that's actually equal to 32, which in this case it is. So we have some equations here that we're just going to check and see if the answer that a student found is the correct solution. So our equations are a little bit different because I have an x squared and an x, but we're going to use substitution to find out if these are solutions. So our first question is x equals 7 a solution to the equation? So in our calculator, what we want to do is sub in that potential solution and calculate it and see if it is, I can't spell calculate today, calculate. We want to calculate this in our calculator and see if it is equal to 70. So 7 with a power of 2 plus 3 times 7 does give us 70. So that means yes, x equals 7 is a solution. Same equation, let's try another x value. X squared plus 3x equals 70. Is x equals negative 10 a solution? So we want to sub in negative 10 and calculate it in our calculator to see if it's equal to 70. So we're subbing in a negative 10. So we have negative 10 squared plus 3 times negative 10. And if we type that into our calculator, we get 70, which is what we wanted to get. So that means yes, x equals negative 10 is a solution. And if you have two answers, you would just do this twice. You would just sub in one answer to see if it's true, and then sub in the second answer to see if it is also true. I want to show you what it would look like if it's not true. So we have the equation 27 is equal to x plus 2 squared plus 10. We want to know, is 2 plus root 17 a solution? So in our calculator, we want to take that equation and we want to sub in 2 plus root 17. And we want to see if that does in fact equal 27. So we're going to calculate this and we're thinking about, is it 27? Does it equal 27? So if I type that into my calculator, 2 plus root 17 plus 2 end parentheses squared and then add 10. I type that in my calculator. And what my calculator gives me is this number, which is definitely not 27. I wanted it to equal 27. So this means no. X is equal to 2 plus root 17 is not a solution. So you can check your answers and see if they are correct or not. And that is especially a great idea on tests. All right, that is it. That's everything for lesson 2. Thanks so much for watching the video. Check with your teacher to find out what your assignment is. Thank you.